want to look at resultant of any number of forces. In the previous video we are looking at resultant of two forces, and I remember noting somewhere that we can get a resultant of any number of forces, not only two. When the forces are two, we saw that we can use the parallelogram of forces, that we could complete a parallelogram and we have the resultant force acting along the diagonal of the completed parallelogram. And now here we have a number of forces other than two. You can have 3, 4 forces which are more than two. And now we are saying that in that case, if you want to get the resultant of those forces, you first of all resolve them into the horizontal and the vertical components. And when you have the sum of the horizontal components and the sum of the vertical components, you shall get two components, one in the vertical and one in the horizontal, and then you apply Pythagoras theorem and voila, you are there. So what do we call a component? First of all, we are saying that the component of the force F in any direction, it is a measure of the effect of the force in that direction. We have this diagram here. When a force F is moving along that line ON, it has an effect both horizontally and vertically. And the horizontal effect of that force is what we call the horizontal component, while the vertical component is the one we call the vertical. Actually, the vertical effect is the one we call the vertical component. The effect of the force in the given direction is a component of the force in that direction. So with this one as angle theta, we have that OY, like OY. Okay, we're starting here with the OX. Realize that this OX is have a cos. It is F cosine of theta. While here OY is same as this one. It is the same length. So having OY and XN, it is the same. So we have that this theta is opposite to this. So we shall have that one is F sine what? F sine theta. But we have the fact that OY, you can take note of this, that OY is equal to F cosine of 90 minus theta. There is a reason why we are writing that, because the definition, it is 90 minus theta which gets us the F sine what? Theta. But you can also get it by looking at it as the fact that if this is our Y, which is it can be small y. Let me use small y. You see that cosine of actually it is sine. This is y. You see that sine of theta is equal to opposite, which is y over f, such that y is equal to f sine of theta. You can use that, but we have a definition of a component around here. We have just seen that the components are f cos theta and f sin theta along with the x and y axes respectively. That is fine. But now we have this. The rule for finding the components may be stated as follows. Take a note of this. We shall use it sometimes, but we can also use another way. But this is it. We are saying that the component of a force in any direction is the product of the magnitude of the force and the cosine of the angle between the force and the required direction. Take a note of this statement. Magnitude of force, product of magnitude of force and the cosine of the angle between the force and the required direction. Understand the components in two mutually perpendicular directions are then always f cos theta and f cos of 90 minus theta, or as these are more usually written, f cos theta, f sin theta. In this case, f is the resultant of those two components. That is what we need to take a note of, that F is a resultant. So let's move to this diagram. I want to look at it, and you see the definition of a component of a force. We said that the component of a force in a given direction is the product of the magnitude of the force and the cosine of the angle between the force and the direction. So if I'm resolving F along the horizontal, I first of all ask myself, what is the angle between the line of action of F and the horizontal? I say that the angle is theta. Then I just say that the component along with the horizontal is equal to F times the cosine of theta. Force, magnitude of force, cosine of the angle between the force and the desired direction. Then if I'm to look at Fy along the y, the component of this force along the y axis, I say, okay, where is the force? It is that one. What is the angle between that force and the positive y axis? It is this one, 90 minus theta. Then I say, therefore, the component of the force along the y is magnitude of the force multiplied by the cosine of the angle between the force and the desired direction. This is how we get that this one is sine of theta, because the cosine of 90 minus theta is the same as sine of theta. That is the component of a force. We have an example here. Find the components of the given forces in the direction of the x-axis, then the other one y-axis. I guess we need to cancel this statement here. This is the direction of Roman 1, the y-axis, Roman 2, the x, Roman 1, the x-axis, Roman 2, the y-axis. Now, from the definition of a component, we said that a component along any given direction can be got by getting the magnitude of force times the cosine of the angle between the force and the desired direction. So the force is 5. The angle between the force, the line of action of the force, and the x-axis is 35. So we have that the component of the force along the x-axis is 5 times the cosine of 35 degrees. And when you work out from your calculator, you are going to get this one as 4.1 newtons. Then the component along the vertical Fy, it is got by getting the magnitude of the force times the cosine of the angle between the force and the desired direction. So this time the desired direction is here. It is 90 minus 35, which is equal to 55. So this angle is 55. So the angle between the force and the vertical axis is 55. This one is supposed to be a y. Take note of it. The file I got you has x there, so that one is supposed to be y. Another y is here. So we have that Fy is got by getting 5 times the cosine of the angle between the force and the desired direction. And when you work out this one, you are going to get 2.87 newtons. That is what we have there. And this one is we just have a 5. We have a 5 Newton force acting along the x-axis. We can still get the components of the forces. Let us use the basics. Let us get from first principles and really get the real picture of what this one implies. So the force Fx that is the component of the 5 Newton force along the horizontal. We say that the definition of the component, get the magnitude of the force, which is 5, multiplied by the cosine of the angle between the direction desired and the force. Now you can see that the angle between the 5 Newton force and the x-axis here is what? Is 0. So we have this force as 5 times 1, which is going to get us a 5. So that force is actually horizontal force. So the effect of the force along the horizontal is still 5 Newton is. Then the component along the y-axis, it is magnitude of force times the cosine of the angle between the force and the desired direction. That angle is 90, and the cosine of 90 is 0. So that force is 0. This one is trying to tell us the fact that the component of a force, if the force is horizontal, it has no component in the vertical direction. And if the force is vertical, you shall learn that if the force is vertical, it has no component along the horizontal direction. The vertical force has no component along the horizontal, and the horizontal force has no component along the vertical. And the whole force is a horizontal component, as you can see. It is 5 Newton is. We have example 2 here saying that a particle is acted upon by forces of 2 newtons, 4 root 2 newtons, 6 newtons, and 8 newtons, inclined at an angle of 30, 45, 60, and 120 degrees, respectively, to the horizontal axis. Find the magnitude and the direction of the resultant. I shall make some bit of a sketch. I will sketch out these forces. Now this one is the analysis of the question. The wordings we have here, can be analyzed into this diagram here. You have a 2 Newton force inclined at 30, 4 root 2 at 45, 6 Newton force inclined at 60, and an 8 Newton force inclined at 120. 120 is towards the positive x-axis. So we have this. I have tried to arrange like this. So we are going to assume that our force is equal to Fx, Fy. So we shall need to get the horizontal components, the sum of the horizontal components, and the sum of the vertical components. Now F of this one can be for the horizontal. We have look at this force, the 2 Newton force. Horizontally, it is inclined at an angle of 30. So we can have horizontally, it is we have 2 times cosine of 30 degrees, and vertically it is inclined at an angle of 30 100. This one is 90 minus 30, so this angle is 60. So it is inclined at an angle of 60, and we have 2 cosine of 60 degrees. Those are the components for the x, for the 2 Newton force. Then the other force we have is the 4. It is the 4. This angle is 45 degrees, implying that this one is also 45 degrees. Well, this force is 4 square root of 2. So horizontally, we have 4. This one is 4 square root of 2 times the cosine of 45 degrees, and the component of the 4 root 2 Newton force along the vertical is 4 root 2 times the cosine of 45 degrees. For this one here, you can actually, let's first finish this. We have the other force is the 6 Newton force to the horizontal, to the positive x-axis is inclined at 60. So you have 6 cosine of 60 degrees. To the positive y-axis, this one being 60, it should be inclined at an angle of 30 here. So this one is 60 cosine of 30 degrees. Then for this one, the 8 Newton force to the positive x-axis actually will resolve along the positive x and then positive y. So along the positive x-axis, this force is inclined at an angle of 120. So we have 8 times the cosine of 120 degrees. Then to the positive y-axis, because this one being 120, this side is 60, and now this one is 90, getting us this angle at 30 degrees. So to the positive y-axis, the 8 Newton force is inclined at an angle of 30 degrees, and we have 8 cosine of 30 degrees. And when you work out everything there, you are going to get the horizontal component is 4.732, while the vertical one is 17.12124. That is our F. This is in the along the X. This one is along the Y. And if you are to get the value of F, we are going to say that F itself is the magnitude of F, which is 4.732 squared plus 17.124 squared, which is going to get us 17.77 newtons. We also need to get the value of the angle, the direction of that resultant can be got by getting the fact that tangent of theta is equal to Fy divided by f of x, and Fy is 17.124 divided by 4.732, and we have that theta is equal to arctan of the same. So arctan of, actually this one is 3.618, and so theta is arctan of 3.618, getting us a value of theta, which is equal to 75.6 degrees. If I write it to one decimal place. This one I got this solution using the definition of a component of force, that a component of a force along a given direction is the product of the force and the cosine of the angle between the force, the angle between the line of action of the force and the direction which is desired. That if I have those two directions, no matter where the direction is facing, if this is angle side F, that one is a force F, and I want it to solve it along with this direction, I just get F cosine of theta. That is what I have, that you just get the product of the force and the cosine of the angle between the line of action of the force and then the direction in question. That is and what I want you to take a note of is the fact that instead of having these two cosine of 60, you could look at this one as complete that, and then the vertical component there would be by looking at this one as the opposite of this, and you have it as 2. Could have it as 2 sine of 30 degrees. It is the same thing. This one could also be 4 root 2 sine of 45 degrees by looking at this one here. And here you could have this one as still as 6 times the sine of 60 degrees by looking at this angle, this one here. With that force, this angle is 60, and you could look at that, and when you drop a perpendicular here, you could be having that this side is opposite to that angle 60, and that is what you could have. Then this one is also the same as 8 times the sine of 60 degrees, resolving this vertically. You could have this side as the opposite to this angle 60. You can have it like that, but you can also use the definition of a component. As for this, somebody could write it as negative 8 times the cosine of 60 degrees here. You could look at this one as x, and then you realize the fact that this one is horizontally, it is facing towards the left, so that one is a negative, and you have it like this. But by having it here, by writing this one based on the definition of a component, you already know that you already see that this one is already a negative half cosine of this, so this one is taking care of the negative. But when you do like this, we try to resolve through this triangle here, you are going to put the negative there yourself by knowing that this force is towards that the horizontal component of the 8 Newton force is directed towards the left, towards the negative x direction. So you put the negative there yourself, knowing that it is that direction. But here you don't need to put it there, because the cosines will be taking care of what is negative will be negative, what is positive will be positive. That is what we can say about that. Let us examine this example. You have 4 newtons, 2 root 2, 6 newtons, and 3 Newton force inclined at the angles as you are seeing them. So they want us to find the resultant of these forces. All of them are inclined that they are all of them acting at that point. They want us to get the resultant and the direction. Now we shall assume that we shall get the resultant along the x-axis. Resultant along the x-axis, we can call that one fx. When look at this one here, this one is 4, and the angle between this 4 and the positive x direction is 30. So this one is 4 times the cosine of 30 degrees. Then plus this one is 4, 2, it is 2 square root of 2 times the cosine of 45 degrees. Then we add on this for this one, that one is 60 times the cosine of 150 degrees. The angle which this force is making with the positive x-axis. I told you we take angles respect to the positive x-axis. If you want to get those angles, if you want to get the components by looking at the definition of a component being the product of the magnitude of the force and the cosine of the angle between the force and the desired direction. So if you are talking about along the x-axis, always think of the positive x direction. Forget about this one, forget about this side, but the positive x. So this one is 60, the force, times the cosine of the angle between the force and the direction, which is the positive x-axis. Of course, this one will be giving us a negative 60 times, it will get us a 60, and this will be negative root 3 over 2. And it is in concordance with the fact that this force is towards the left, and the forces are negative in that direction. So by having 6 cosine times cos of 150, it is already becoming a negative. Somebody else could say that this force, the component of this force along this line, then they can say that it is negative 6 times cosine of 30. So it is either this or this one here. This one takes care of the negative, but for this one you must know that the negative, that a force which is in that direction should be negative. I prefer to use the definition of a component, and we have it like that. The other force is 3 Newton force, which is equal to 3. The angle between that force and the positive x direction is 180. Someone could just say that now that force is negative 3. It is because it is along the horizontal. It is purely horizontal and towards the negative. So it should be negative 3. And however, if I use this from the definition, of course cosine of 180 is negative 1. And you can see that it still comes to this negative 3. So the forces to the left are negative, the ones to the right are positive, the ones whose components are toward the left are negative. And that one is being seen by using the definition of a component. If you are not using the definition, you resolve them, but you put the negatives yourselves there. You put them yourself. When you work out everything there, you are going to get that the horizontal component involved there for all of those forces is going to be, maybe I can try to simplify here. This one is 4 times root 3 over 2 plus this one is 2 root 2 times 1 over root 2 plus this is negative 6 times root 3 over 2, because cosine of 150 is negative. Actually, maybe let me write it like this: 6 negative root 3 over 2 plus this is 3, then negative 1. And when you work out everything, you are going to get negative 2.732. That is fx. Then we get the component along the y, fy. This force has a component along the y, which is got by getting 4 times the cosine of the angle between that force and the y-axis. That is 120 degrees. The y-axis is like there, and this angle here, the angle we are talking about is this. That is the angle, because you are resolving this one along with the positive y-axis. So the angle involved is 90 plus 30, which is 120. Then somebody could just say that this one along with the y, you could say it is 4 sine of 30 degrees, but it is negative because that component is moving downwards. Yeah, but you can also have it like this. And then this 4, this 2 root 2 force is you have 2 root 2 times still cosine of 45, because this force is inclined at an angle of 45 to the positive y-axis. Plus, we come to this force also, 6 Newton force. We have 6 times the cosine of 60. This force is inclined at an angle of 60. This angle here is 60. It is about force times the cosine of the angle between the line of action of the force and the direction in question. Then the 3 Newton force, it should not have a component in the vertical, so it is basically 3 times the cosine of 90. because the angle between the 3 Newton force and the positive y-axis is 90. When you work out everything here, we're going to get basically a 3. So we have that the resultant force F is equal to square root of negative 2.732 squared plus 3 squared, and that is going to get us 4.058 if I write that to 3 decimal places. For direction, you realize that the horizontal component is towards the left because it is negative, and the vertical component is positive. So the force F is moving like that towards the left and towards the upward direction, because positive for y means up, and the negative for x means towards the left. So you can look at the angle theta. The fact is that the tangent of theta is equal to opposite over adjacent, and the opposite is the x value. Of course, here we are not putting the negative, we are just looking at the value of that angle theta, which is an acute angle, so we don't need to put the negatives. So we simply have 3 divided by 2.732, which is equal to, I can just have theta here as a tan of 3 over 2.732, which is equal to 47.7 degrees. And now if you are to get the angle of inclination of the resultant to the positive x-axis, this is the angle, and that is the angle we are looking for. So the resultant is inclined at an angle of 180 minus theta. 180 minus 47.7. This one gets us 132.3 degrees. So you can able say that if you are to conclude, if you are to make a conclusion, we say that the resultant is this one, 4.058 newtons, inclined at an angle 132.3 to the positive x-axis. That would be our conclusion. I want you to attempt this question and submit your answers in the, just write your answer. You can just maybe give me the final answer, that is give me the components, the x component, the resultant x component, the resultant y component, and then the angle of the resultant force. Try to work it out to show that you are making some progress. Equilibrium of forces. A body can be in equilibrium, and when we talk about equilibrium, there is what we call dynamic equilibrium and then static equilibrium. And because here this one is we are talking about statics of a body, we shall deal with particularly here static equilibrium. And now if a body is in a state of static equilibrium, it means that it is not showing any preference to move in any direction. And that one means that the forces in any direction they are balancing. The forces in any opposite direction are balancing each other out. That if you have the left, for example, the forces toward the left are balanced with those on the right. Upward forces are counterbalancing the downward forces. That is what we can say about equilibrium of forces. And we are seeing that when you have the conditions that must be satisfied for a body to be in a state of equilibrium, the first one is saying that the algebraic sum of forces in any two opposite directions must be 0. Now, algebraic, the learning point is this: algebraic sum. It is not just a sum, but algebraic sum. So if we talk about forces like these two, you have this force 5 newtons, you have another force of 10 newtons, and you have another one of 6 newtons. If we talk about the algebraic summation of these forces, we shall have 5 plus 10 plus negative 6, because in the algebraic summation you cannot have forces in the opposite direction is having the same sign. So if we take the forces to the right to be positive, we take the forces towards the left to be negative. That is in the algebraic summation. So the algebraic summation contains some direction being positive, another being negative. So telling us that the algebraic sum of forces in any two opposite directions must be 0. It means that the sum of forces in one direction is equal to the sum of forces in the opposite direction. That is what we can say about this condition. The second condition is that the algebraic sum of moments about any point must be 0. Algebraic sum of moments about any point must be 0. Still, if we talk about algebraic sum, still the word is there, algebraic sum. If we are talking about moments and we are talking about algebraic sum, it means that if the clockwise moments are taken to be positive, then the anti-clockwise moments should be taken as negative. So you take one side to be one direction of moments to be positive and another one as negative. That is in the algebraic sum. Those conditions are satisfied for equilibrium of a body. We have this example. 3 forces act on a particle at O, as shown above. Oh, this is not above, man. This one is below. It is shown below. In the particle, if the particle is in equilibrium, find the value of the one that find the value of r, Roman 2, the value of theta. So they are saying that this particle, the particle which is at this spot here, is in a state of equilibrium, implying that the resultant force is not tending to make the body move in any particular direction, that the forces are counterbalancing each other. And now, if you try to resolve these forces in two perpendicular directions, you can think of, for example, vertically along the positive, along the y-axis, and then horizontally, preferably along the x-axis. So you can resolve these forces vertically and horizontally, and we can look at those 4 directions: positive y, negative y, positive x, and negative x, and look at those forces, and they should counterbalance still the forces, the algebraic sum of the forces in those directions. So we can assume, let us try to resolve the forces vertically. You are supposed to write this in when you are answering. You say that resolving vertically, the vertical component of this, if I try to make this one completely like that, the vertical component of this force r, this one is opposite, this side is opposite to that theta. So vertically we have that r times sine of theta. That's the vertical component of r. The other vertical component is this force has no vertical component because it is barely horizontal. It is purely horizontal, not barely, but purely horizontal. So it has no vertical component. The other vertical component we have is the 5 Newton force, which is acting downwards. So this one is upward. The upward ones must be equated to the down ones. So r side is equal to is equal to 5. I can call that equation number 1. This one can also be got by using the particle is acting at the force is acting there, and you are trying to resolve the force along the positive y. So you can just look at the definition of a component. The component of r along y is equal to r times the cosine of 90 minus theta, and still it comes to this one here, the one we have just written there, we have just wrote. So horizontally, resolving horizontally, this is another thing you should write. Resolving horizontally, we have that the horizontal component of this is r times the cosine of theta, and that one should be counterbalancing, this is to the left. R, the horizontal component of r is towards the left, so it should counterbalance the one which is to the right, which is 8. So horizontal component, this one to the left, counterbalancing the 8. In other words, we are having that to be in accordance with rule number 1. Horizontally, you have r cosine of theta plus, actually it is supposed to be 8 plus negative r cos theta equal to 0. That is what that law is saying. Algebraic sum of the forces in any direction is equal to 0. So horizontally, this is 8. Then r cos theta is towards the left, so we have it as negative. And when you work out that, you come to this expression, that this one going that side, you have 8 equal to r cos theta. And the same apply to the first one. You are having that vertically, you have r sin theta plus negative 5, which is acting downwards, should give us a 0. This is the algebraic summation we are talking about. And now here we can write, you can find the angle theta. They want to find r first, so we can say that if this one is equation number 2, you can have equation 1 squared plus equation 2 squared, and you have r squared sin squared theta plus this one is r squared cos squared theta equaling to 5 squared plus 8 squared. You see that this is r squared in 2, this one is cos squared theta plus sin squared theta, getting us 25 plus 64, and we have that r squared is equal to 89, because this one is 1 from trigonometry, so r is equal to square root of 89. You can get that from the calculator. And then when we get equation 1 divided by equation 2, we have that tangent of theta is equal to 5 over 8, and theta is equal to the tan inverse of 5 divided by 8, which is equal to, this one will get us 32 degrees. And those are the values we have here. I guess you have followed that. Proceed. Forces of A in the I plus 2j, I minus j and 3i plus b act at a point and are in equilibrium. Find the possible values of A and B. They are talking about forces which are already in the various components, and understand that the forces are in a state of equilibrium. When the forces are equilibrium, we have that the summation of those forces, the algebraic sum of those forces, will be 0. And now by having the forces given in the form of their components, some are negative, some are positive, they are taking care of the algebraic summation already. So we just have that we sum up all the forces and we equate to 0. So we are saying that at equilibrium, This implies that we are saying at equilibrium summation of f equal to 0. So in this one you will imply that I have ai plus 2j, you add on I minus j, you add on 3i plus bj, and you equate to 0. When you get this one is now like algebra of vectors, the one we did in vectors. So just look at the i's. When you look at the i's, you have a plus 1 plus 3, that is I, plus the j's, you have 2 plus negative 1 plus b. This one is in the j, everything is equal to 0. Now if the vector is like this and everything is equal to 0, that vector should give us a 0, then it means that the individual components should be getting us a 0. So the implication of this statement is the fact that when I have this one is a plus 1 plus 3, I don't know why I'm putting 2 pluses here, but there we are. So we are saying that when I get a plus 1 plus 3 equal to 0, from which we have that a is equal to negative, a is equal to negative 4, and we also have that 2 minus 1 plus b is also equal to 0. The individual terms, the individual components are going to be equal to 0, from which b is equal to negative 1. Just sum up the components and equate to 0. Try to work out this number, and try to find out that theta is equal to 23 degrees and the value of s is equal to 6.5 newtons. Try to work out that and show that you are progressing in this video series. We have triangle forces here. Triangle forces. This one is saying that if 3 forces acting at a point can be represented by the sides of a triangle, and the forces act in the same sense around a triangle, then these forces are in equilibrium. So like here you have this one, y in that direction, z in this direction, and then x in that direction. We are saying that if you can represent them like this, like you can see x there, then you have y there, and then you have z there, and you have that the direction of the forces are in the same sense. Like you can see here, all of them are clockwise. You can see y, z, then this one is x, y, z. That is the same sense. That is basically we are talking about as a triangle of forces. So as that if it is possible for us to represent the forces like that, then the forces are in equilibrium. And sometime later we shall see that we have that the converse of the triangle of forces is also true. The converse of this, we are saying that if the 3 forces can be represented by the sides of a triangle, and you have that they are in the same sense, around the triangle the forces are in equilibrium. So it means that when the forces are in equilibrium, the converse is saying that if 3 forces acting at a point are in equilibrium, they can be represented by the sides of a triangle. A theory and its converse, both of them are true. If you can draw a triangle from the forces, then they are equilibrium. Then the converse is that if the forces are in equilibrium, then you can have a triangle from those forces. That is triangle of forces. So one, you can see the way x is. If it was possible, we could just get a ruler and have the same inclination. This is horizontal x, and even this is horizontal. Then the inclination of this one is the same as the inclination of that. So you draw this one where the other one was ended, bearing in mind that the inclination is what are the same. That is if you are doing it to scale. But in most cases, we don't draw it to scale because we are just trying to draw a sketch to help us solve our problems. Then the z, the same inclination. So don't say, where is he? How are they getting that? We are maintaining the directions of the forces. We are maintaining those directions. This example is saying that given that the system of forces shown in the diagram is in equilibrium, sketch the triangle of forces and hence calculate the magnitude of the force x and the angle alpha. We shall sketch the triangle of forces. We have a horizontal line that is 424. Where that one ends, you have the 7 Newton force upwards, and where that one ends, you have another force in that direction. And that one is basically like our triangle forces. You have 24. You maintain the direction of the forces, I told you, and then 7 Newton vertically upwards, and then x. You can see that the slope of this is that. Then this one is horizontal, then this one is. And now where is alpha? Well, look at this alpha. It is the angle between 24 and x. 24 is here and x is there. The only point we can think of 24 and x is this point here. And it is not this one. The angle is not that. Because for this, x is into and 24 is out. And the point is this, x into 24 out of the point. So we cannot have that as the angle. We need to extrapolate either this one, the 24, so that all of them are coming towards the point that this one is coming and this one is also coming, or we can have we can extrapolate this. That is what we are doing. Extrapolate the x so that you have this angle as alpha. That's the angle alpha. And we can call this other angle, we can call this one theta. Call this one theta. Alpha is the angle between 24. And I remember telling you the other day that what does it mean to have that alpha is the angle between the 24 Newton force and x. They must be starting from a common point here, and both of them are either away or both of them are coming towards that point. And so here, both of them are away. So the point which is in equation, it is here, where the two forces, the 24 and the x are acting, is there. And away means that this one is towards that direction, and this one is also towards that. Not this case where this one is coming, is entering there. So that is basically our diagram. And because this one is horizontal and this is vertical, it means that they are perpendicular to one another. So we are going to use Pythagoras theorem. We are going to use Pythagoras theorem. So by Pythagoras theorem, we have that the sum of the squares of the two short sides is equal to the square of the hypotenuse. So we have that x squared is equal to 49 plus should we do that? X squared is equal to, this should be 625, such that x itself is 25 Newton. Is the value of theta. You can see that tangent of theta is opposite 7/24, and theta is arctan of that same thing, 7/24, getting us a value which is equal to 16.3 degrees. But remember, I want to get alpha, so there is no way you can get alpha without getting theta, so we got theta first, and now alpha is equal to 180 minus 16.3, so alpha is equal to 163.7 degrees. I guess that one is that. This example sketch the triangle forces for the system of forces which is in equilibrium. Calculate the magnitude of P and theta. We can still get the triangle forces. We have the horizontal force, which is 8 newtons, and where that one ends, we can put the 5 Newton force. Can have the 5 Newton force there, and then where that one ends again, we can have the P. That is what we do. Ensure that they are in the same sense. So we have 8 in that direction, followed by 5 in that direction, and then we have P in that direction. Now, what is angle theta? Where is 60? Actually, we have the angle. 5 Newton force is making an angle of 60 with the horizontal. That is not angle between 5 and 6, not 5 and 8, but it is the angle which the 5 Newton force is making with the horizontal. And then when they gave us that P, the force P is making an angle of, by moving like this, it is making an angle theta with the horizontal. And so if that is the angle theta, it is also that one, because these two angles are vertically opposite, because this one is horizontal there and this one is P is in this direction, making an angle theta. So that angle is also theta. And now for this one, we are going to use the, if you are following this, we are going to use the cosine rule. We are looking for P and also looking for theta. So from the cosine rule, we have that P squared is equal to 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of the angle opposite P, 60 degrees. This one will get us that P squared is equal to 49 and P is equal to 7 newtons. That one is if you press your calculator. P is equal to 7 newtons. Then we can go on to use the sine rule to get the value of theta. So we can have that 5 divided by sine of theta. This we are talking about this 5 divided by the sine of theta. It is equal to P, which we have just got, divided by sine of 60 degrees, implying that when I try to cross multiply, I have that sine of theta is equal to 5 sine of 60 degrees divided by P, which is equal to 7. Sine of theta is equal to 0.6186 such that theta is the sine inverse of the same, and theta is equal to 38.2 degrees. I don't know whether it's making some sense to you, but I hope so. If it is making sense to you, then try out these numbers. You have this file, you have that file. Try out these numbers and try to get the solutions to them. This one, that, and that. Try out those problems